When you go to a party, have you seen these disco balls like this? The disco balls are made of tons of little mirrors that are all flat and they are glued on top of a sphere. What is interesting is that every little mirror is a plane mirror, but because it's on a curved surface, it allows us to have light and it makes amazing patterns in our party space. Now, how does this work? It is when we use the theory behind the reflection of light on plane mirrors. So let's see if we can answer that for you. And let's see if I can show you example to help you trace images of objects with plane mirrors. So let's see, stay with us. Okay. Okay, so we have, let's see, plane mirror. Let's see. Okay, can we see it nicely? Perfect. So let's review the theory we have about the reflection of light with plane mirror. We know that if we have a plane mirror and we have a light ray, a ray of light going towards our mirror here, we have what we called an incident ray. Incident ray. We also know that where this ray touches the mirror, we have an imaginary point that leads us to a vector, and that vector is called normal. The normal is at 90 degrees with respect to the plane mirror. The reason why the normal is important is that when you have this incident ray touching the mirror here, we have the slight ray that is being reflected. This is called the reflected ray. So we have a reflected ray like this. Now, this brings us to two other concepts that are amazing. The first one is about what we call the incident, the angle of incidence, and the other one is angle of reflection. So this one here is angle of incidence, and this one here is angle of reflection. So what we have here is that we have these two angles that are exactly the same. So let's see if I can write down this vocabulary for you. So we have angle of incidence and angle of reflection. The idea here is that the more we understand the principle behind these concepts, the easier it is to understand, the better you will succeed at school. The whole idea here is that my beliefs is that once you learn something and you can put it into action because you understand it, that's when you have some transformational understanding of what science is, first of all. But second, succeeding at school can be tough for some, but once we understand, it makes life so much more fun. So here, this is the theory behind the reflection of light. Now, from here, what can we learn? If I have an object in front of a mirror, then there's an image being done. So, for example, take a moment, pause this video, go into you can go to the washroom, or if you have a mirror, look at yourself in the mirror. You know that you are a human being with a body, a physical body. You have a mirror in front of you, but the mirror shows you as a reflection. But you also know that you are located behind the mirror. So you cannot touch the image because it is behind the mirror. If the mirror is on the wall, it's as if you were in the wall. But you know that the image exists because you can see it. And you know that your body exists because you're here. The whole idea is, how can we trace the image of an object using light rays. And that's what we're going to do together. So let's see. Oops, there's no more juice here. So this is the symbol for, let's see if we can have a focus. Let's see. Perfect. So here, this is the information I have for my mirror. It is a plane mirror. And let's see if I can put we're going to do something that is easy. Let's do a pen like this. Perfect. We know that this is an object. The object is a physical object. So you could take a marker like this. It is in front of the mirror. But you also know that there is somewhere behind the mirror an image. And the question is, where is that image? In order to do that, we need to trace light rays. So what I'm going to do, I'm going to take a light ray that will go here through the tip to the mirror here. But we know that when the light ray reaches the mirror, which is a flat surface, we have an imaginary line, which is the normal. And that normal tells us where the reflected light will be. And the reason for that is that we have the angle of incidence that is equal to the angle of reflection. So this is a light ray that is coming from the tip here and is reflected. We also know that when we look at an image, it is behind the mirror here. So the light that goes here is reflected. So that means that there is an imaginary line that we can find behind the mirror like this. That brings us to a second line. So if I take another line and I go from here to this point right there, this brings us to a point, which is an imaginary point from which we have the normal, like this, and for the normal. But we have a reflected ray, and we have, so the ray is going this way, it's being reflected this way. And then we have here the angle of incidence equal the angle of reflection. But interestingly enough, this is reflected on the real world, but we have an imaginary line that could be at the back here as well. Let's do another line that is interesting. If I have a line that is going like this, that is perpendicular to my plane mirror, this ray is in line with our normal like this. So that means the angle of incidence equals 0. That means the angle of reflection also equals 0. And therefore, the light that goes towards the mirror will be reflected on that plane. But that also means that there's an imaginary plane, an imaginary ray that is going behind the mirror as well. Now that's interesting. I made here 3 lines. We have here the 3 rays of light that are meeting at this point. Interestingly enough, we have also 3 lines crossing at the back here. And that's quite important, because if the 3 rays meet here and the 3 rays meet there, that means that my image will be right here. And we can actually find the exact location of that image. Now, often in my class, people are saying, yeah, but you put 3 rays and they met there. And therefore, it's always easy because you make it look easy. That's possibly true. But what if I was to use any other light rays? If my light ray was going here, it would be reflected there because of the normal. Oh, it does meet at this point. If I have this ray that is going here, we have ray of the incident ray, the reflected ray, they are meeting there as well. So it doesn't matter really what angle you're using. You need to look at specifically how is, in this example, where the light is reflected, where the light is reflected, where it is reflected, where it's reflected, always using the same principle. If you have a flat mirror, you have an incident ray that will touch the mirror here. At this point, you have a normal that is perpendicular. You have the angle of incidence that equals the angle of reflection, and we have a reflected ray. So this part here is the theory that was applied here, 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 and here. And that is how we know that if we have an object here, we have an image at the back. Now, interestingly enough, there's some other information we can figure out. The first one is that if you have here an object like this, you have a distance between the object and the mirror, and that becomes the distance of the object. So the distance between the mirror and the object. But that also means that you have a distance of the image. The distance of the image, di, is the distance between the mirror and the image. Other things to keep in mind is that you have here the height of the object here. The height of the object here is from the bottom to the top. Interestingly enough, if you go at the back here, you also have what we called the height of the image. So here you could see that we can actually start measuring entities. We can measure some specific characteristic of the object with the height and the distance from the mirror, and characteristic of the image here from the height of the image and the distance of the image. And that becomes important because in the next few videos, I'm going to share with you how this information can be used when we have curved mirrors. So let's see, before we finish this video, if I can give you another example of how this works. Basically, how you can trace where the image is. So let's see if I can do another example. If you've enjoyed the video so far, my name is Alain Faber. I've been teaching science for more than 25 years. There you go. I am doing these videos for my students, for students I tutor, but also from anybody that will be looking for how to better understand science. I use questions from my students and students I tutor to find ways to have great videos, but also from your comments. So if you need any answer to one of your questions, put the question in the comments below. If you have any clarification questions, put your clarification questions in the comments below, so because I always read them, and that gives me ideas for future videos. So let's see if we can look at another example with a plane mirror. So here I'm going to trace my plane mirror like this. Perfect. I'm going to give so often, so why not? So I'm going to give an example of, let's see, it will be an object that is at an angle. So we're going to have, what can it be? Let's see. So we have like this. We have a house like this. What I want to do is I want to be able to figure out where the house is. So here, what I need to do is figure out, this is the object. This is an image that will be behind the mirror. Now, I'm not going to do all the points here. So what I'm going to do is I'm going to take some this away, comes to C. So I'm going to look at 3 specific points only, but you could do that for other points if you wanted to. I'm going to do the tip of this roof, the edge of this roof, and the base right here. That will be how I will find where the image is on the other side. So the easiest way to do is that if you take a ray that is perpendicular, so let's do it this way. So we have a ray that is perpendicular to the mirror, we have our normal, and therefore we have a light ray that is going back this way. So that means that we have a ray that is in line with the reflected light. I'm going to do another ray of light. So here's another incident ray going this way. We have our imaginary point here. We have a perpendicular line right here. That means that we have a reflected light like this. And that means that if you go here, you have the intersection at the back here. So I'm going to do a third line, but for the other two, I'm going to just do two because the drawing will get crowded. If I was to get, let's see, a light ray that will go like this to this point, we have our normal, the incident, the angle of incidence here equals the angle of reflection, and we have here the reflected light, and here we have the two lines that are meeting right there. So that means that we have here three rays of light, meaning at this point on the object, that means that the three rays of light that are meeting here will be the meeting point for the image. So these 2 points will be the same. So that means that what we can do for the other two. So if I have this one right here, so let's do a ray of light going this way, then we're going to do the same principle. We have a normal right there, and then we have the reflection right there. So the reflection goes like this. If we have, let's say, a ray that is perpendicular to the plane mirror like this, so the rays goes this way. We have a normal that is right here. The angle of incidence and reflections are both equal to 0. That means that the ray will go back to the same place. And this is where they will meet. I could do a third line here. So if I was to do a light going this way, being reflected, they would meet to this point. Now it's interesting because we have 2 points for the objects, and now we have 2 points for the image. So that means that if I was to link these 2 points like this, that means that I have this first side of my house. So let's see if I can do another one. So let's take pink for this one. I have my third point. I'm going to go here. We are perpendicular to the mirror. We're going to go this way. Angle of incidence equals 0. Angle of reflection equals 0. That means that the light will go back. And we have, so the light ray goes in. When it goes away, this is the imaginary line going behind the mirror. If I am to go this, let's see, we have a line right here. Oh, my mirror is not long enough. So this light ray touches my mirror. I have here my normal, which is perpendicular. We have the incident ray here. We have here the reflected ray with the angle of incident equal the angle of reflection. And here we have the ray that is extended at the back. So here we have an intersection point here. Let's see if I can get purple. The intersection point is right there. So here, so my drawing is not up to date, up to scale. But here would be where we have our house there. How was I able to figure out where the image of this object will be behind the mirror? I do the light rays for the plane. Now, if you look at this one, you're going to say, oh, this looks so complicated. It may look like complicated, but if you break it down into simpler steps, like the theory behind the reflection of light with an incident ray, reflected ray, where the angle of incidence and reflection are equal. So this complicated drawing, if you look here, you have one small part, we have one small part, one small, one small, one small, and one small. We are taking one ray at a time, and you can bring back, so you can go on the video and go back a little bit and look at how I traced each of these. And this allows me to trace the image of an object when we have a plane mirror. And as I mentioned before, if I take some of these away like this, so from this point to the mirror, I have the distance of the object. Here I have the distance of the image, and they are the same. We have here the height of the object. So I put a little O here for object, and we have here the height of the image. I stands for image. The whole idea here is that you can start putting measurements for here, and that's how we can use more and more what we know about light to make this happen. So this is my second video on how light is reflected. Hopefully you've enjoyed this. If you have any clarification questions, put them in the comments below. I'm going to read them. I always look at your comments and your questions to bring the next video. On this, if you've enjoyed, please subscribe to our channel, and I'm going to put here another video that you will enjoy.